of Behavioral Physiology here at the FBN in Dummersdorf, and it is my pleasure to chair this first session of this symposium. And so I will start off with introducing Rebecca Nordquist, our first plenary speaker of our symposium. Rebecca is an assistant professor at the University in Utrecht in the Netherlands, and her research interests are farm animal behavior and welfare, and also neurobiology of farm animals. And I'm really looking forward to hearing her plenary presentation today. And with this, I hand over the floor to you, Rebecca, wherever you are. I cannot see you right now, but I'm sure you are there.
Yes, I am here. Let me try and figure out how to get to the share screen from here. Because now I can see all of the people. No, here we go. Share screen. Can you see my screen now?
Yes.
Okay, excellent. First off, let me say how excited I am about this meeting. I think, like most of you, I was looking forward to this last year and was hoping to meet all of you in 3 dimensions, but well, life got a little different this year. But I am also very glad that you decided to continue this on as a virtual meeting. I think it's extremely useful for us to all get together in this format and talk to one another about cognition and farm animals. There are not all that many of us working on this in this field, and it's so helpful if we can talk together. So thank you for inviting me. Today I'm going to talk about my research on which is mainly focused on pigs and on poultry. And on effects of early life management on cognition and on neurobiology of pigs and poultry. I'm going to take a couple steps back because most of us are working here in farm animals and looking at cognition. But I think it's important for us to take a few steps back and think about why we're doing this, because it's important to be able to communicate that and to think about it for talking to each other. To start out with, I work with pigs and with poultry, and there's a very strong public perception of both pigs and poultry in terms of how people generally look at them. When you talk about pigs, you get dirty pigs, happy pigs, which are outside playing pigs. You get there are a lot of sayings that have to do with pigs and with other farm animals. Eating like a pig, which is generally considered to be sort of eating whatever you can get hold of, and unbridled eating. And there's also, so this is on the one hand how people view pigs as sort of happy fats playing around outside. On the other hand, there's also the book that influenced many of us as going to high school. At least this was required reading at my high school, and I think many of us read this. So Animal Farm. When I talk to people in the general public about I do research on cognition in pigs, I get a lot of reactions. Oh, pigs are very smart. Animal Farm, yes. So there are very differing perceptions in the public on the cognition of pigs and how important that it is to them, and whether they're smart or whether they're not actually that smart. And it's something that people sometimes think about. It sometimes makes them uncomfortable to think about, since we do eat pigs. Chickens, on the other hand, have a very different public perception. So people generally tend to regard chickens as not very bright. So stupid chicken. Chickens are not regarded as intelligent animals. People are generally more inclined to say, okay, this chicken is not very bright. And when you look into thinking about the way that they're portrayed in the media, they're often portrayed as cute little chicks. And I don't have any. am interested in this discussion this afternoon on public perception and cognition in animals, because when looking for pictures of chickens that are sort of in a cartoon way, they're either portrayed as not very bright, as stupid chickens, or as sort of emotionless beings. So, which is certainly not to say all the time, but just looking through pictures, this is what I usually find. So people have a specific way that they look at animals and the way that they look at animals that we eat. And in although people clearly do recognize that chickens are capable of cognition, and in a somewhat disturbing thing that I found, there was actually an arcade game that was a video-operated arcade game, and I assumed that this was in the 1930s or something, but it was actually in 1975, where you could, this was a carnival game where you could play a chicken on tic-tac-toe, which I think is is done in most countries with the X's and the O's and the it's called butter, cheese, and eggs in Dutch. But so it was, you could pay to test your own cognitive abilities against a chicken. And apparently the chickens were very good at this and frequently won. I really, this may give me nightmares given how they were probably housed, the chickens that did this, but there is a public perception that chickens are not very bright. And if you can be beaten by a chicken, well, then you must not be very bright either. I think it's important to keep this in mind when we're talking about what we're doing here and how we're working on animal cognition and how that's presented to the public, and how we talk about that to the public. Because I get a lot of questions on why. Why would you care to study emotion, and particularly cognition and neurobiology in farm animals? Do we really care if farm animals are intelligent? Are there, maybe a pig is better off being not very smart, because then it doesn't notice as much if it's not being challenged on a farm. So is there a problem if our management or breeding processes are causing animals to be less intelligent? Well, I believe that this is a problem. I think that there are probably a lot of people here who believe that that cognition is related to animal welfare, but I think for myself, it's also important to talk about why and to figure out, what the reasoning is behind that. So for me, there are three main reasons why I think studying animal welfare and emotion and cognition are important. First off is the practical. Animals have to be able to thrive on the farms that we're making for them. And farms are, after a long period of industrialization of farms and making them basically less complicated for animals through individual housing and things like that, farms are starting to become increasingly complex for animals to thrive on. So you get things like social housing, which is almost certainly an improvement to the lives of animals, but it does mean that they have to be able to deal with more space. They have to be able to remember which animals are where in the social hierarchy. That may be more animals than they actually, especially in the case of chickens, than they actually want to deal with. So there are all kinds of things that that tax their cognitive abilities. I actually, in one of the slides that came by, I saw the feeding stations that are used in group housing of sows. So where they are implanted with a chip and then the doors open and they can get their individual feed. That is almost a classical conditioning experiment. So animals need to be able to figure out how to use these things. And especially with gilts, we do actually see that is a problem. Some of them just never really, it takes a long time for them to figure out these feeding stations. So in a practical sense, animals have to be able to deal with the challenges that we're sending their direction. Then there's the ethical part. Cognition, neurobiology, and development of animals is part of their intrinsic value. So the idea behind intrinsic value is that it's the value that we give to animals that is outside, or the value that animals have that is outside of the value that we give to them. So particularly in the case of farm animals, there's a very strong economic value to these animals. You can put a number on how much a piglet costs today. They also have value as companions. They can also be other kinds of value to humans. But aside from that, they also have intrinsic value, which means that we need to respect them and respect that intrinsic value. And if things that we're doing in terms of management are changing their cognition or neurobiological development, that's an ethical issue because we're infringing on their intrinsic value. And finally, and I'm actually really excited, to, as I said, about this breakout session later on, because I think understanding the emotion and cognition and neurobiology of farm animals is important to humans for better understanding of animals and being able to empathize more with them. Now, as far as I know, there's no actual research on how much people know about the cognitive abilities influencing their empathy. I do know there's research going the other direction. So if people are shown animals and they're said that they're either animals which are going to be kept on a farm forever and live happy lives, or they're animals which are about to be eaten, they'll give the animals which are given which are said to be leading happy lives, they'll say they're smarter than the animals which are the same species which are going to be eaten soon. So there's a very strong connection in humans between how much they empathize with animals and how much they're inclined to say animals are intelligent. So better understanding in scientists and also in the general public could increase our empathy for these animals, and that may also lead to us being able to better design farms, better understand what they need, and regard the animals just more as intrinsic beings. So I work at the Behavior and Welfare department in the farm animals at Utrecht University. We've actually all changed names now, so but my main focus is behavior and welfare. The idea, I came to this group in 2008, and we started it up with the idea that we'd like to identify welfare issues based on scientific evidence rather than gut feelings. I think many of us have had the experience of seeing political decisions made that are not based on scientific evidence, but are based on what people think that animals may need, which in the end may be not what it may be what they need. It may not be what they need. It may be worse for them than when they started out. There are examples of that where, you know, I wonder, the beak trimming ban in the Netherlands, we moved from being allowed to trim beaks in chickens to only being allowed to use infrared beak trimming. So where the tips are treated with infrared and then gradually break off. While I think banning beak trimming was probably a good thing, there was no real evidence at that time that infrared beak trimming was better for the animals than what we were doing before that. These kinds of decisions, you need to have a scientific basis to make improvements in animals' lives. We also wanted to look at long-term effects of management and breeding practices, particularly in early life, because in a lot of farm animals, early life isn't as well studied as later on in life. If you look at chickens, for instance, early life is particularly understudied. Most of the laws and regulations are related to, particularly for laying hens, the period that they're on the laying farm, and not the period before that. I'll get to that a little later. So there are different ways that we focus on welfare measures at the individual level. There are different ways that you can look at welfare measures at the individual level. You can decide to look at physiology, things like hormone levels, heart rate, and respiratory rate. You can decide to look at the neurobiology of an animal, or you can decide to look at behaviors, and you can sort of divide those into spontaneous behaviors, learned behaviors, or pathological behaviors. We've looked at all of these things in various projects throughout the past years. For today, I'm going to focus, oh, excuse me, I can't actually see that part of my slides. Let me move all of you a little bit out of the way. Sorry about that. For brain measures, you can look at neuroanatomy, microdialysis, or imaging. So for today, I'm going to focus on these three things. So a little bit about, mostly about learned behaviors and cognition, a bit about neuroanatomy, and at the end, I'll very shortly talk about some of the things we do with hormone levels. I am going to focus mainly on the story of why and how, and a little bit less on the results and data. Feel free to ask questions along the way or later on. I'll be here for the next 2 days. Now, I'll get a little bit back to my background here and talking about where this came from for me. I'm a psychologist by training. So my background before I started in 2008 with farm animals was mostly behavioral testing in rodents and neurobiology in rodents, which is a very different field in terms of cognitive testing. There's 60 years of history that you're building on in testing in cognition in rodents, and there's really very little that you can come up with that hasn't been tested before in some form. So it's a very different knowledge base. Coming from psychology, when I came to looking at farm animals and testing cognition in them, which felt like where can I start here? There's just so much to do, which was on the one hand exciting because so much that you do is new, so much is unknown. On the other hand, it was a little daunting because there wasn't this knowledge base to build on where you could say, okay, we already know this and we're moving on from there. Now, obviously, there were people already working in cognition in farm animals. Most of them, or many of them, are here today, but the vast body of knowledge is not the same. So being a psychologist, I went back to the basics. I thought we need to start with putting together a test, and that needs to be valid for one thing. This is sort of the roots of what kind of testing you can do. And validity is, am I testing what I want to test? Does my test really tell me in the end something about the cognitive processes that I'm hoping that it will? And particularly when looking at cognition, one of the main challenges there is separating out cognition and anxiety. So animals are often very afraid of the test setups that we're putting them in. Things like habituation and handling are extremely important. And so putting together a test, thinking about validity of what you're measuring is extremely important. I also wanted to put together a test that could be reproducible. So can this be done in my lab? Can this be done in other labs? Can this be done by me and by other people? When you're thinking about reliability in terms of testing, you also have to think about how much training do you need to do to teach someone else to do this same test? So can it be explained on paper? Can some of it be automated, which means that it's a little bit less dependent upon who's running the test. It's still dependent because the person has to be moving around animals, but it's a little bit less dependent. So validity and reliability as sort of the core areas that to start out from. You also have practicality, so you can think of this, think of some kind of beautiful, amazing test, but you also have to be able to do it in the place where you are. You have to have access to the species that you're working on. You have to have the space to build a setup. You have to have the know-how around. So all of these three basic things are important when thinking about putting together a a test in terms of starting a new test for cognition in animals. What we decided on was to put together the Holeboard test for pigs. The Holeboard test has been run in many species. We published a review on that, and I think we got up to, I mean, it's even been run in hedgehogs and other kinds and very exotic animals. The idea is that there are, in the case of the pigs, there are 16 spaces where rewards could be hidden. 4 of those places are actually rewarded. In our case, we used M&Ms. This arena that you see, I'll show you a video in a minute, and it'll be a little bit easier to imagine. But the idea is that the animals need to find the same 4 rewards every day in the same place, which is spatial reference memory, so long-term memory. And they have to remember not to go back to the place where they've already been, which is where have you already been this trial. You can also measure behavioral flexibility with this test. So if you do a reversal, looking at whether the animals had go back to the same place where they were, looking for the same rewards or not. This was an attractive test to start out with for a couple of reasons. One of them was that it's been done in so many other species before. There was also the opportunity to automate a lot of this. I'll show you that when looking at the video. And it's also a test which gives you, in a single test, a lot of different measures. Working with pigs and other large animals is very work intensive. And so it's very helpful if you can measure something that's going to tell you a bunch of different things at the end of the day. I'll get to the video. I'm going to apologize beforehand because it starts out with sound and it's very loud. I will turn the sound off as soon as I can. Here we go. This is giving me the opportunity to turn it off beforehand. We have a radio in the background, which I think you all don't need to hear. Here you have a pig entering our setup. The balls which are on top of which the pig is pushing away, there are magnets inside those, and underneath the dishes there are sensors, and all of this is attached to an interface in a computer which measures how far away the ball is from the sensor. So every time an animal moves the ball to look into the dish to see if there's an M&M or not, that's recorded. The order of the visits is also recorded, and all kinds of other latency measures are also recorded. As you can see, this was a pig which had done this task several times before, but they get really good at it and really fast. Pigs really do well on this task. We tried a number of, obviously before getting to this point which we built, we tried a number of different setups, but this really worked very well for them. In part, I think, because it takes advantage of their natural behavior, their rooting behavior. So they like putting their nose under things and moving them away, and that's what they're doing in this task. So by this point, we've run, this is actually in a slide that I put together some time ago, and I think we're up to 12 experiments now, independent experiments showing similar performance of controls in this task. So this speaks to the reproducibility of the task. What you want to be able to show is that animals can do this repeatedly in an experiment run by different people with similar learning curves. So what we're looking at here is a graph on the, I don't know if you can actually see my mouse moving around. But what we're looking at here is the top graph is working memory. So this is the short-term memory of pigs, and you see that they get to almost ceiling levels immediately. So they're very good at remembering what they've already eaten and where they've already been. If you look at reference memory, they learn the reference memory very quickly, and their learning curve is very steep. And what we're comparing here is two different, conventional pigs. So this was a land-raised mix that's used on farms here in the Netherlands a lot, so from top eggs. And compared to Göttingen mini pigs, which are an inbred strain which is used a lot in research. And you see that the Göttingen mini pigs learned a little bit slower than the conventional pigs, but in the end, they got to the same level of performance. We see, I'll show you some more results on some of these different things when I get to what we use this test for. But we see that things that you would expect to impair cognition on a whole board actually do. So muscarinic receptor antagonist piperidine and iron deficiency both impair performance on the whole board task, which you would expect based on results from other species. We also show improvements in working memory in the task, which is an important thing because often tasks are so well suited to animals that you can't see any improvements above their cognitive ability. So things that are improvement, there is room for improvement in the task. And some things have no effect at all. So we showed also no sex differences in prepubertal animals, animals in this task. Okay, so now we had a task which is reproducible, reliable, can be used to look at different things. Now we can get back to the questions, looking at early life and effects of earlier experiences on farmed piglets. Now, there are various periods in a farmed piglet's life, and I think many of you already know this, but I'm not sure of the background of everyone here, so I'm going to run through this quickly. You have a farrowing period, which is usually in a farrowing crate, with the exception of Switzerland's and some of the some newer systems. But by and large, sows are put into a smallish area where they're confined, and there are some good reasons to do this. And that area is where the sow gives birth and where the piglets stay for the first 3 to 4 weeks of their lives. There's the suckling period with the sow and litter mates, which are probably the animals that you were born in the same litter as, but cross-fostering happens a lot. So animals which are taken from one sow and given to another, depending upon how large the litter is and whether the sow can deal with all of the animals that it has, or whether an animal might be lagging in growth and not ready to be weaned yet. And then there's weaning, which is usually combined with mixing the animals. So usually the litters are mixed together. Talking about early life of a farmed piglet, there are so many potential threats. I realized after I put this picture in that that maybe it looks like there's something wrong with these piglets. No, these are very chilled out piglets who are just hanging out on one of our PhD students, previous PhD students, showing that the habituation apparently went very well there. But there are so many potential threats on a farm during early life for a piglet. It can actually be a very dangerous place to be. Early weaning is one of them. So most piglets in the Netherlands, they're supposed to be weaned at no earlier than 28 days of age, which if you compare to natural weaning is earlier. There are some exceptions that can be made in which the piglet can be weaned earlier from 21 days of age, which is very early for a piglet, and that actually happens a lot. I think the situation is very similar in a lot of places in Europe and in the United States, as they're often weaned between 21 and 23 days of age. So this is really very early for them. All kinds of painful manipulations, so tail docking, castration, and etc. Large litter sizes, which is an increasing problem in pigs, and also stressful for sows. So pigs have been bred to produce increasingly more piglets per litter. We've shown that sow or litter size is actually correlated with hair cortisol in sows. So sows which are producing larger litters also show higher cortisol levels. And large litter sizes mean often low birth weight, because just like any other kind of mammal, the more animals you put into a uterus, the smaller they are when they come out. It can also mean long farrowing, and it can also mean competition for food when the animals are born. Repeated mixing, including cross-fostering, and later on, once weaning has happened, the piglets are usually sorted by size and not by keeping litters together. A lack of rooting or foraging possibilities, which is on the one hand a behavioral need, and on the other hand, since piglets generally would, pigs out in the wild would generally get their iron from the ground, so from eating things, from basically eating dirt, they have an iron shortage when they're born and usually need to to get more iron supplemented. So this is just a short list of many things that could go wrong in early life in pigs. And I'm going to just pick two of these to talk about for a minute, to show some data on in our Holeboard experiments. What we see in looking at iron deficiency in piglets, it leads to long-term memory issues. So that's actually one of the most salient results we've seen with the Holeboard and with the working memory. So what we see is decreased reference memory, so long-term memory. This is the white line here at the bottom. In iron deficient piglets compared to controls. Now, what's important to know here is that these piglets were iron deficient for the first 4 weeks of life, then they were repleted for another 2 weeks, and then they were tested from then on. So these final measuring points are 8 to 10 weeks after they've been repleted for iron. So this is something that causes very long-term effects, the lack of a lack of iron, and that it seems to be irreversible, at least for as long as we were able to keep the piglets on. Yes, there we go. We did a whole series of studies related to low birth weights and size of litters. And what we see is that low birth weight is a good predictor for things going wrong in learning. So at least various deficits in spatial learning. In this case, you see also here that there's a deficit in long-term memory, so in reference memory, in the animals which were born with low birth weight compared to animals which were born, litter mates, which were born with normal birth weight. The results have been a little bit variable. So we've seen in various studies that what we usually see is that there is a difference in working memory, which is sometimes significant and sometimes not. And what we sometimes see is that there is a long-term difference in long-term memory, a long-term difference in long-term memory. There we go. So what you see is that these early life adversity has long-lasting effects on cognition in pigs. What we also saw was that from the other side, that looking at the positive side, so enriched housing, leads to an increase in reference memory, so in long-term memory, compared to animals which are kept in barren housing. And in barren housing, in our case, was basically the legal minimum. So you could also say that the barren housing that we're usually keeping pigs in is actually decreasing their cognitive abilities. But in any case, if you compare the legal minimum housing to housing with more space, with peats to root in, with regularly changed toys, you see that the animals which are given enriched housing show better cognition. Just also looking at the neurobiology behind this, what we also see is that early life adversity has long-lasting effects on the neurobiology of these animals. So looking at the iron deficiency versus control and the hippocampus, Iron deficiencies during early life caused decreased hippocampal iron deposits in pigs that were also related to and correlated with how they performed the reference memory task. So animals which showed less iron deposits also performed worse in our Holeboard task. And keep in mind that this is a long-term effect. So these animals have been, this was done after the behavioral experiments. So the animals had been repleted for about 10 weeks before this was done. So these are long-lasting. This is not just an effect of whether they had iron in their feed at the time that they were sacrificed, but this is a long-lasting effect that apparently causes permanent changes in neurobiology. So early life adverse and positive effects in pigs show spatial learning and memory effects in the Holeboard. And the Holeboard is not the only task that we've developed. We've also done judgment bias tasks and a pig Iowa gambling task. We've also worked out a pig Iowa gambling task along with a couple of other things, but I wanted to focus on the Holeboard task as something that we've developed and validated, I think, probably the most. In the most of our tasks. It also affects neurobiological developments. This is from the pig side of the story, but what about an animal that we have even more of on farm? So we have a whole lot of pigs in the Netherlands, but we have even more chickens. I think I wanted to make sure that we are all on the same page talking about referencing how chickens are raised and what they, and the phases of life. So talking about how a chicken egg gets to be a chicken egg in your supermarket. There are different types of farms that lead to different types of products. So to start out with the breeders, so these are parent stock. These are chickens which produced fertilized eggs. So there are chickens and roosters together that produce fertilized eggs, which then go to a hatchery. At the hatchery, the animals are hatched, normally in very large room-like hatchers. And once they're hatched, they are sold and shipped as day-old hens. Now, this is talking about obviously egg laying and not broiler chickens. And in this case, you're talking only about the hens. So this has been particularly in everywhere, I think, but particularly in Germany, a recent heavy discussion on what to do about with the roosters that are included here, or the roosters that are born or that hatch from all of these eggs, because we only actually use the hens, because the hens are then sexed, sorted, vaccinated, and shipped to rearing farms, where they spend the first 17 weeks of their lives, and then they are sold as 17-week-old pullets. At 17 weeks, they're just about ready to start laying, and then they are moved to a laying farm, where they spend a little more than a year usually. And there they produce eggs for consumption. Now, in this whole story, most of the legislation and most of the, and for good reasons, a lot of studies have been focused on the laying period, because this is where most of the animals, this is where the animals spend most of their lives. So clearly improving conditions in the laying phase will improve conditions for a very long period of the animal's life. On the other hand, rearing has been largely under-investigated. It's getting more attention in the past couple of years. Anja Bryn-Schreiber and Andrew Jensek wrote a review on rearing some time ago, and there are a number of projects, including project that the Chicken Stress Project, which is an ITN, which we're involved in as well. Rearing is getting more attention, but it's still we still don't know enough about the effects of early life on later life. And I sort of compare this to, it's like saying we're going to start looking at children when they get to high school and improve the high schools and not look before that. Clearly, early life is going to have a major impact on how these animals develop. So looking at chicken early life, there are so many potential threats on the farm, you almost don't know where to start. There's a lack of maternal care or older chickens to learn from. So chickens are in an all-in, all-out system. So they come in as day-old chicks, and then later on they're taken away to whatever next part of the farm. There's potential crowding. Generally, in the Netherlands, at any rate, the number of chickens per square meter is regulated from 17 weeks of age. Before that, it's not. So there's no real rules or regulations around crowding for very young chicks. Transportation. So transportation from the hatchery to where the chickens are going. In the Netherlands, that's generally very short, but this could be in some areas really far distances. There's also a lack of space to learn about spatial cues and flights, which may be important to them depending upon what kind of area that they're going to be in afterwards, what kind of housing they're going to be in as adult chickens. Potentially painful procedures like beak trimming, sexing, which is often underestimated. So sexing of a chicken is very invasive, and a lot of them are damaged during sexing. To the point where they don't survive or have very serious health issues. Sorting. So these are all potentially painful procedures. I'm going to talk a little bit about housing conditions during rearing here today, aviary versus caged conditions, and maternal care, looking at the neurobiology and corticosterone. In a project that we did together with Andrew Jansek and Faye Tamtani, who was the PhD student working on this and has now gone off to postdoc through all of Northern Europe now. She's gone from Denmark on to Sweden. We looked at the conditions of cage-reared birds compared to aviary-reared birds. So you see here in a single housing unit, which was in Norway, and this is really nice that they have access to a unit like this. On the one side, the animals were raised in cages, and on the other side, the animals were raised in an aviary tier system. And so they were kept there until 16 weeks of age, and then brought to the experimental facility, where they were all kept in the same type of housing, and Holeboard testing was conducted at 18 weeks. So once again, yes, the Holeboard. Here we have chickens and the Holeboard. We weren't sure when we started it out on this whether the chickens would actually be able to do it. So you see we have 9 here compared to the 16. This was probably a prejudice on our part against the chickens. So we thought, well, we'll start out making it a little easier for the chickens. So there are 3 rewarded places here. We did this with grapes, although Maeva is the PhD student on the ITN is actually working with mealworms again now. My chickens love grapes, but apparently these chickens don't love them as much. 3 out of 9 of the locations are rewarded, and you have the same reference memory and long-term memory measures that you can use. So looking at this is a very complicated and long graph, so I'm just going to point out here at the at this part that's in yellow. Being raised in a cage has negative effects on short-term memory, so working memory following reversal. So there's something about being raised in a cage that compared to being raised in an aviary, which makes your ability to deal with behavioral flexibility in spatial learning tasks more difficult. So housing conditions are important. The way that you are raised and in what kind of housing conditions are important. But what about social input? So how does a chicken learn to be a chicken? If we look at rearing conditions and maternal care, I'm going to this is a chickens are usually raised as an all in, all out with all in, so with all of the same aged chickens, which means there's no maternal care or other chickens to learn from. And we wondered, what does maternal care do for chicken cognition and neurobiology? Well, and are there practically feasible alternatives? Because there are very good reasons why all in, all out is used, which mostly have to do with biosecurity. Well, to get sort of through the basics of maternal care and behavior in chicks, a lot of authors have found positive effects of of maternal care on fear behaviors, but the effects are often small and inconsistent. In our lab, we've done several studies using looking at maternal care and behavioral tests on both fear and cognition, and we find very few effects of fear we find very few effects of maternal care on fear or cognition. The effects are small, they're not very reproducible in our hands. That sort of surprised us because you would think maternal care would be a big thing. We also kind of wondered, okay, we're not seeing it so much in the behavior, but what do we see in the brains following maternal care? Well, we do see that hen-raising chicks changes the neurobiology of chickens into adulthood. So this is a study looking at the brains of chicks, which are of chickens, so adults, which were raised either with or without a mother hen, and comparing them to chickens raised with a mother hen. Or excuse me, chickens raised with or without a mother hen. And we see in the adults that there are changes in the laterality of the hippocampus, so changes in the way that the hippocampus left and right develop. We also see that it changes the neurobiology of the hypothalamic vasotocin, which is another hormone which is related to sociality. In the hypothalamus, we also see that adult hens raised with or without a mother hen show differences. And as a final thing to talk, as a final study, I wanted to quickly point out, we looked at dark brooders because obviously, for those of you familiar with chicken farming, looking at or adding adult chickens is not going to be a very feasible process. There are just too many biosecurity issues in terms of wanting to include maternal care with hens. But one possibility is looking at alternatives that may provide at least some of the care that you would like to have looking at chickens. So dark brooders mimic some of the aspects of maternal care, like having a dark and warm area, and having an area that is that can be separated for the animals that are sleeping and not sleeping. And Anja Brins-Reiber, who did this experiment, who was the collaborator for this experiment at Aarhus University, found a lot of effects of dark brooders on feather pecking later in life, so that they seriously reduced feather pecking later in life. We actually, she had to stop this experiment early because the control group was showing such extreme feather pecking, while the dark brooder group was showing minimal feather pecking. So we looked at effects on the brains of these of these chicks that were raised in brooders, and what we saw was that there was an effect of age. So animals which were either at 16 weeks, which were sacrificed either at 16 or 28 weeks, but we really didn't see any effects of the brooder, the brooder on hypothalamic vasotocin, which surprised me because I thought that there would be more effects comparable to the maternal effects that we saw before. We also looked at corticosterone in feathers as a measure of long-term stress, and we didn't see any effects of the brooder on feather corticosterone either. So despite the fact that there were these very strong behavioral effects, we didn't see any effects on either the brain or in corticosterone. So summarizing this on chickens, housing conditions in early life are very important. We've seen in other studies that undercrowded chicks showed less fearful behavior. Overcrowding produces corticosterone at later ages. and that aviary reared birds show better working memory. On the other hand, maternal care shows inconsistent results, and that the neurobiological changes that we see in animals that have been provided with an actual hen, we don't see when we provide with alternatives. So basically, getting to sort of the end of my story here and the take-home message, early life conditions affect neurobiology, cognition, and fear behaviors in pigs and in chickens, but different conditions affect different welfare measures. So no single measure here is going to give you the answer in terms of welfare, of measuring welfare. So all of these things are necessary, interacting with one another. I wanted to leave you with this idea that I think it's very important that those of us working in animal behavior and working particularly in cognition of farm animals really work towards communicating why we're doing this. I think it's important, and this is my idea of why we're doing this. Other people may have different thoughts, but I think it's important to communicate to the public that cognition is part of animals and part of why and part of their value as animals. And as a final, I'd like to thank many people who worked on all of these experiments, including people at Utrecht University, Vivienne Goerlich, Maeva Manet, Susie Hewlett, and Ellie Zijnstra, Frans-Josef van der Staaij, who is now retired, but who was instrumental in starting up the Holeboard experiments, and a couple of my collaborators. And that was what I wanted to talk about today.
Thank you very much for this really excellent presentation, Rebecca. And I think this is now open to discussion. I see a few clapping hands and I see one raised hand by Jean-Loup. Please go ahead and ask your question.
Hello and good morning, everyone. Thank you, Rebecca. Very interesting presentation. I was intrigued by one of your last slides when you talked about the rearing experience and showing the old behavioral differences, but there was, you said it may not mimic the effect of maternal care to induce brain changes. As we know, like behavior and behavioral control must have some kind of neurobiological substrate or underlying mechanism, right? So do you think that, I know you look at a lot of places already in the brain, but could it be through a mechanism that you did not look for or did not investigate in this study? And if so, what part of the brain do you think could underline these behavioral differences?
So you're asking about what do you think is underlying the behavioral differences that that Anja sees in the studies that are on the I had a little trouble understanding, but just because of the sound. Well, there's always the possibility that you're looking at the wrong area. And I think that obviously we were looking at the wrong area here, that it's just not the same area as what we saw with the actual hens, because as you said, if there's a change in behavior, there must be something going on in the brain. You know, there are a lot of things that have to deal with that the dark brooders deal with. One of them, I think, may be the sleep issues and activity synchronization issues, which may be just located in a completely different place. Usually when you have these large groups of chicks, they don't do well synchronizing their sleep and wake. So what you end up with is that chicks who want to sleep keep being disturbed by chicks who want to be awake, and chicks who want to be awake keep being disturbed by chicks who want to sleep. And the dark brooders at least give like a resting area and a non-resting area, which makes it a lot easier for chicks to rest when they want to. I think maybe that would be an area in the brain that would be worth getting more, looking into more.
Thank you.
Yeah, next up is Liza. Please state your question.
Yes, hello, thanks for a great talk. Two brief questions, one for pigs, one for chickens. For the pigs, I'm really interested if you looked at the developmental aspects of the spatial memory in those pigs. So are the piglets worse at this? How does that development work?
Yeah. Do you want me to answer this, or do you want to?
And the other really quick question, then I'll mute myself. With the chickens, you mentioned these differences in AVT that's related to social behavior. So maybe, I mean, it is weird that you don't find cognitive differences, but maybe something to look at would be social cognition or social behavior. And is it a direction you're interested in checking, or do you have the data to look for that as well?
Yeah, to start out with the pigs, we haven't done any systematic comparisons between ages. What we did do was, because for practical reasons, we wanted to start one of our studies looking at very low birth weight. So you have low birth weight and very low birth weight. We wanted to start that earlier. We wanted to start training earlier. So because those animals were such low birth weight, they wouldn't have been able to survive on the farm. So we had taken those animals and into the facilities and were basically hand-raising them. And we wanted to start training after 2 weeks, and that just didn't work at all. That didn't work at all. They just didn't get it. So in the end, we were training them for until they were about the same age that they would have been had we started at 4 weeks before they got it. So I think there really is, we just got lucky that weaning age is about the age where they start understanding the task when we started doing this. And previous to that, they really do have a lot of difficulty with it. Looking at social cognition in chickens, I think that's certainly an interesting area. We have done a little bit of work on that. So looking at preference testing in a Y maze, whether they prefer to be with chickens they know or chickens they don't know, or chickens versus foraging areas. And we still don't see any differences between hen-raised chickens and non-hen-raised chickens, which doesn't mean that they're not there. I do think, though, that when looking at commercial chickens, that a lot of this may have to do with selection. I think we have probably selected these chickens such that they thrive, or at least do better, without a mother hen than an unselected chicken would be. That's not something that's selected for on purpose, but if they weren't doing well as chickens without hen raising, then they wouldn't be here now. So I think that may have been, I think that there may be some selection issues there.
Next question, Anissa Dude.
Hi, thank you. Can you hear me? Yeah.
Yep.
Okay. Thank you for the talk. That was very nice and very interesting. And I do cognitive experiments with chickens as well. And I have a very general question. So I don't know whether we can answer that now or we can discuss this maybe later. But you said that as I experience as well, there are many prejudices against chickens and their ability in society. So that these experiments might help to explain the society that chickens are aware about their environment and so on. But I always wonder whether this is also some kind of misleading, because if we say these animals have a higher cognition, so they are more valuable, or we should treat them better, that would maybe or can exclude the other animals which don't show these cognitive abilities in other experiments. So there is no ethical correlation between the cognitive abilities and how we should treat animals, right? So I think there is, I mean, this is interesting and important, but it can also, it has two sides, so to say.
Yeah, it's an interesting discussion. It actually came up recently. There was this, I don't know if you've seen this paper on cuttlefish. There was a recent sort of kerfluffle on that cuttlefish actually apparently can show social learning, and so octopi can show all kinds of complex learning abilities. I think there are probably, if you're asking the question in the right way, there are probably very few animals that can't show cognitive abilities on a complex level. We're just not asking the question in the right way. And it is, you know, I think it's more part of understanding what an animal is, and that it's more than just either just the cute fluff of a chick, or the egg that ends up on your plates, or the chicken that ends up on your plates. That there's more behind the animal. That it's the animal itself is complexer than we're used to looking at it. But I think you are correct. I mean, we shouldn't be excluding animals or making animals more important because they are smarter. So it is an interesting discussion.
Okay, now we have like a 1 minute left for a final question by Jan Langbein, and Matteo, I will have to ask you to go and search for Rebecca at our lunch breakout sessions. I'm sorry.
Okay,
Jan?
Matteo, you can go first. I'm the organizer. You are the guest. Please go first.
Or like that.
Okay, thank you. Well, thanks to Rebecca for the wonderful speak. Also, is making my life easier because my presentation also is going to in this path. I had 2 quick questions. One for pigs. Did you consider the intrauterine growth reduction? And I don't know, what do you feel about the anatomical maybe suffering of the brain? And I've seen that you have used some indicators from markers in the brain, like iron in the brain, in the cells of the brain, that can be considered a long-term effect. And you were studying some behavioral, so some cognitive aspect of the animal. Would you consider also other brain indicators that have a short-term effect? So what could you suggest to look in the pigs or chicken to see brain indicators in the short term?
Okay, thinking first about IUGR, we have done some studies trying to, most of our studies separate out by birth weight. IUGR is basically the runts that have a very specific morphology. So they have, they show morphological underdevelopment. I think that they probably also are more more delayed in development, and I think they probably also show more long-term problems. This was one of the reasons why we decided to look at the very low birth weight animals. We used this, we used animals that came from a farm, so our faculty farm, and on that farm, if they are very low birth weight, they don't survive. So the IUGR animals, I think, usually don't make it to weaning, which is why we use these small for gestational age, basically, animals. I think it's a very interesting question to look at. And we may also see, as the number of piglets per litter is increasing, that the IUGR piglets may increase as well. But I think they may have separate issues, which would also be very interesting to look into. We just made the decision to look at the small for gestational age animals based on birth weight. Looking at short-term things in terms of looking at short-term changes in the brain, then you have to move to in vivo things, which I really would like to do. I mean, I think looking at electrophysiology in animals would be really, yeah, I'd really like to be able to do that. Apparently, it is difficult to look at EEG signals in pigs because they have very thick skulls. And I wouldn't want to get into looking at these kind of things invasively because that just is an entirely different ball game. I have been involved in studies in chickens using microdialysis, which is invasive, which does give you some really nice real-time data, but it is an entirely different, you know, you have to look at them individually because they have to be implanted and they can't be housed on a farm. They have to be housed in experimental setups. And if other people have ideas on this that would be able to be done in an intact animal, I would be very happy to think along on that, because yeah, looking at real time in the brain is difficult.
Thank you for this final question and answer. And with this, I would like to move on to our next speaker.